Hello and welcome to today's webinar, Combine Technology and Creativity in the Classroom with CTC GO. Thank you for taking time out and being here. Just a few housekeeping notes before we jump in. We'll be running a live question and answer session towards the end of the webinar. Please feel free to use the chat feature on your participant panel and pop any questions you may have in there, and we will address them when the time comes. Also, if you miss any part of the content presented today, we'll send all registrants the on-demand recording when it's available. We'll also be delivering certificates of attendance to all our attendees today. Please turn those in for professional credit if you're able to do so, and we will email those certificates following the webinar using the addresses you provided during the registration process. My name is Steph Forbes, and I am the Coding and Robotics Channel Manager for PITSCO Education. With me today are two colleagues from PITSCO that I am very pleased to introduce. The first is Aaron Locke, PITSCO Education Curriculum Specialist. Physics, family, and faith are the 4 F's that define Aaron's life. With a degree in physics from Pittsburgh State University, Aaron has always been drawn to how things work. Wanting to pass on his ambition led him to PITSCO Education, where for the past 16 years, Aaron has worked as a curriculum specialist, writing hands-on curriculum and activities. His main focus lately has been in the area of coding and robotics. Aaron is married to his wife, Katie, and together they have 3 incredible kids who share their dad's interest in how things work. Aaron and his family are also heavily involved in their local church. Last but certainly not least is PITSCO Robotics Application Specialist, Tim Langford. Tim is a perfect example of the saying, all roads lead to Rome, inferring that similar outcomes can be reached via many different paths. For him, the satisfaction that comes from personal exploration and discovery of how things work, compounded by the act of sharing that discovery with others, uncovered a love of education. Luck and Providence took over from there, and Tim accepted a position with PITSCO Education, an employer that offered the opportunity to develop his passion regardless of background. 20 years later, he still enjoys a creative process of exploring how things work, finding ways to translate that into cool robots, and sharing with the world. At night, he goes home to a cat who is gracious enough to allow Tim to share her home and be her caretaker. Thank you, Tim and Aaron, for being with us today. Today, we'll be sharing information with you about Arduino Education CTC GO core module and motion expansion kits. These kits make it easy to deliver STEAM lessons to your students while creating an engaging setting where students want to learn. Students can utilize their creativity as they learn about the foundations of programming, coding, and electronics. Before we begin, I'd like to give our audience a bit of a background on the sponsoring organizations of this webinar. PITSCO Education is a leader in future-ready learning, fundamentally rooted in STEM. Our competency-based and collaborative hands-on solutions effectively integrate core disciplines while helping learners master the transferable collaborative, critical thinking, and problem-solving skills that will last a lifetime and translate to any college or career path. For more than 50 years, we've offered a comprehensive range of scalable hands-on resources and curriculum. We help educators create learning environments that address all learning styles and help all students find success while solving problems, being creative, articulating ideas, and thinking with their hands. It's our goal to make it easy for schools to bring materials to the classroom to create lifelong learners, successful professionals, and engaged citizens. We promise to remove barriers to bring cutting-edge technology into the classroom and to help teachers find new, relevant ways to do what they do best. And now a bit about Arduino Education. At PITSCO, we are so very proud to partner with Arduino Education, whose classroom and remote learning solutions progress students through STEAM and from middle school to university, increasing in complexity to challenge them as they develop their skills. Arduino was founded at the Interaction Design Institute in Italy, with the goal of making technology simple to use. You can see here the 4 founders. The founders' goal was to enable anyone to create and innovate their own projects by making technology that is affordable and accessible to all. All Arduino education programs include a range of electronics such as programmable boards, sensors, accessory, and mechanical parts. Simple open source software, online content for students to build hands-on projects, and guided training and support for educators and parents. The products students learn with are the same as those used professionally in companies around the world, such as Google, Fitbit, and Parrot, and applications like rapid prototyping, AI, drone technology, and developing machine learning. Though we're exploring CTC GO today, you can see the entire Arduino education continuum of kits here, which you'll notice extends all the way through post-secondary. Each of the kits in their assortment build on the knowledge that the students gained from the previous kit, ultimately teaching them important STEAM learning concepts. So now I'm going to turn the session over to content experts, Aaron and Tim. Take it away, guys.
All right. Well, to begin with, Tim, I think we want to show a video just to introduce you to CTC GO.
Well, let's watch it.
Oh, I think we're missing the audio. There we go.
CTC GO is an educational program consisting of different modules that can be combined to teach different STEAM subjects. Inspire high school students with a set of playful, hands-on experiments grounded in the real world. With the core module, students go through the foundations of CTC and build 8 exciting projects based on teamwork and learning by doing activities, understanding electronics and text-based programming language. Building on top of the knowledge gained from the core module, the 4 projects of CTC GO Motion's expansion pack focuses on adding mobility to the projects. Students learn to control motors, translate rotational and linear motion, and write more complex programming concepts. When building CTC GO projects, students will follow a design process to develop their competence, creativity, and knowledge in computer science and engineering design. Get yours now.
Well, that was a great video, but Aaron, can we start and expand on that just a little bit with a high-level overview of CTC GO?
Yes, let's do that. So CTC, it stands for Creative Technologies in the Classroom. CTC GO is a modular kit, and it's recommended for students ages 14 through 17, so your typical high school student. Each CTC GO kit has 8 sets of hardware in it, and so we recommend that the teacher have students work in groups of 3, and then each group having their own set of hardware. So that means that one CTC GO kit can serve up to 24 students. Students start with the core module, which gives students a foundation in electronics and coding, and then it engages students with hands-on activities to build devices that apply these concepts. And so along the way, students use a design process, talked about that in the video. They use that process to develop their creativity and competence in engineering and computer science. There's also an expansion pack called CTC GO Motions Expansion, which we'll cover a little bit later in the webinar. CTC GO is aligned with national standards such as the NGSS in the United States and the national UK curriculum in England, and it's available in English, Spanish, French, German, Italian, and Portuguese.
Well, that's a great look from a high level, but can we look a little deeper at maybe some of the key learning values you might get in CTC GO?
Yeah, so first, students gain an understanding of the basics of electronics. I mean, that's what Arduino is all about, is these electronic devices, right? So how to read schematics, how to connect commonly used electrical components, resistors, LEDs, those kind of things. Second, they'll also understand the basics of text-based programming, where they use code to control their components and gather their data. So that's the other thing that Arduino is known for, is coding.
Sure.
Students will also explore creative ways to use technology by designing and developing physical computing projects. And then lastly, students develop those important 21st century skills, such as working collaboratively to tackle real world problems within given constraints and instructions. All of the lessons and activities and projects that are delivered to the student are delivered to the students using online educational platform. So the CTC GO core module includes both lessons and guided projects, and we'll take a deeper dive into those here in a little bit. But for the teachers, the platform also includes extended content for managing and facilitating student learning. So this includes a starter guide for the program, lesson and project guides, content and discussion tips, timing and pacing suggestions for classroom management, tips for troubleshooting, that all-important solution code, so you have the right answer to the code, and then additional resources to help with lesson planning.
From a hardware perspective, the kit's hardware is powered by the UNO Wi-Fi Rev 2 development boards, and it also includes education shields, electronic components, and modular pieces. Everything you need to complete all the activities and projects is provided in the kit.
As for software, Arduino is also known for their software. Students code their devices using the Arduino IDE, which stands for Integrated Development Environment. But the IDE is more than just a code editor. It does the job of compiling the code into machine language that the microcontroller can use to understand and do what it needs to do. So all those bits and ones and zeros and all of that. It also does the job of transferring the code onto the device itself. So there are two versions of the IDE. There's an offline version that's a free download, or there's the web-based IDE that's accessed through any Arduino account. This makes the coding environment compatible with nearly all devices and computers. Tim, why don't we dive into the specifics of the hardware a little bit? What's included in the set?
Sure. So besides the 8 UNO Wi-Fi Rev 2 development boards, the kit also comes with 8 education shields that attach to the UNO. Also included are cables, LEDs, resistors, breadboards, photo transistors, buttons, and more. It also includes plastic construction pieces that are used to create the projects, and these are modular and can fit together in many different ways. Now, the education shields are boards that can be connected on top of a control board to extend its capabilities. These shields make prototyping easier and reduce or eliminate the need for soldering, meaning the pieces and components can be reused. This is vital in education. The education shield is designed specifically for the CTC and has a collection of features that make it easy to use and include things like a plug and play port for sensors and servo connections, an SD card reader, audio port, second independent breadboard size specifically to fit the shield, and accessible reset button.
Okay, so that's everything that's in the kit, but what about the hardware? We talked about how there's 8 different groups working throughout the kit. So what about the hardware that each group has?
Sure. So here you can see the items that are included in a single kit. As a reminder, there are 8 of these kits in each CTC GO set, and each of these group kits is housed in a larger toolbox, which also includes the modular pieces, a variety of jumper wires, arcade buttons, batteries, copper tape, and a box of extra components. Now, since we've looked at the hardware components, let's take a look at the content that makes it that whole complete package.
Sure. So the core module comes with access to an online platform with 8 lessons and 8 guided projects. The content is divided into 2 parts. So part 1 is going to focus on digital inputs and outputs. And then after completing a series of 4 lessons, students develop projects where they build, wire, and code a series of fun tabletop games. We got an example here to show you here in a little bit. Part 2 is going to focus on serial and analog inputs and outputs. And again, students complete a series of 4 lessons, 4 guided lessons, before they dive into more advanced projects that relate to current and near future analog technologies. Then CTC GO culminates with an open-ended challenge project where students bring everything that they've learned together throughout the 2 parts. They get the opportunity to design, build, and program their own device that meets some kind of technological need or solves a technological problem. All the content is designed by the Arduino Education team, and it features illustrations, slideshows, there are videos, there's assembly animations, a lot of other resources. There's a glossary of terms, all kinds of things that students can use to build their knowledge of coding and electronics.
Sure. So it seems to me that when I'm looking at all that, this adds up to about 20 class periods of content and activities. However, little birdie told me that this can be extended up to 38 class periods. How does that work?
Yeah, so each project time, consists of 3 class periods to complete the project. So that's an estimated 135 minutes given an average class period of about 45 minutes. Now, each kit comes with enough physical materials for 2 groups to complete each project at the same time. So 2 groups of 3 students working on one project, let's say the finger racer, while another 2 groups work on a different project, maybe the pinball game. Another 2 groups work on the 3rd project, the React game that we have here. And then the last 2 groups work on the 4th project, the whack-a-mole game, my favorite.
Yeah.
But that project time can be extended by having groups rotate through the 4 different projects. So for each group to rotate through all 4 projects, it would take approximately 12 class periods at 3 class periods per project.
Now, you mentioned 4 specific projects, but there's actually 2 parts, correct?
Yeah, that's right. So here's a look at the 8 different projects that students can rotate through. It's recommended that students go through the 4 guided lessons first before they dive into the digital input and output part and start on those projects. And then the second half continues with the serial and analog input and output part, including 4 more guided lessons followed by 4 new projects that students can rotate through. All right, so here you can see some of the built projects that we've been mentioning. Students create these in part 1.
No, let me,
Okay, you go ahead.
because I love the project. So like in the finger race, the green LEDs indicate when the game begins, and then players race to push their button 30 times. During the race, the blue LEDs indicate the player that is winning. And when a player reaches 30 button presses, the LEDs flash to indicate which player won the race. Then there's the pinball. Players get 3 chances to shoot the ball into the top goal. Misses are tracked by the blue and red LEDs. And when a ball is scored in the goal, the green LED lights up. And then everybody's favorite, hopefully everybody remembers this, the whack-a-mole arcade game. In this variation, the yellow LEDs light up briefly at random, giving players a chance to hit the corresponding button. And when a button is whacked, the green and red LEDs indicate whether a whack was a hit or a miss. And then last but not least, in the React game, players score points by reacting to the LEDs. The first player to press their button showing during the short time interval scores. So we've actually got this project set up, and Aaron and I are going to have a showdown here live on the webinar. So just going to warn everybody ahead of time. Old man here versus young man. So I'm probably going to lose, but I'm going to give it my all. So let's go ahead and let's give it a shot, right?
All right, so we've just got our 9-volt battery plugged in here. You can also power it using the USB cable from the computer. So right now we're in a wait mode. You can see that all the LEDs are flashing here and is waiting for the game to begin. So Tim and I are going to take our positions. I have the advantage because I get to use my right hand.
He's already got it stacked against me, but let's go ahead.
All right, so to start the game, we're just going to push a button. Go ahead, Tim. And now we're going to react to the green light when it turns on.
Ah, the old man gets first one. Two.
Get on my game here.
Uh-oh.
I think my button's broken. Oh, nobody got that one.
Oh, he's coming back. Uh-oh. The old man took it. Look at the old man took it.
All right, I want a rematch later.
Okay, so those are the projects for the digital input and output section. And here are the projects that are associated with the serial and analog inputs and output parts. Now there's the Morse Alien, Crazy DJ, the personal trainer, and AR glasses. Now these all sound pretty cool, but for the sake of time, because we know you're going to do this anyway, we're going to encourage you to check these out online as you investigate more about the CTC GO.
All right, so as students work through these different projects that we've just talked about, they develop a variety of skills and responsibilities. Students in each group can choose different roles for each particular project. These roles and responsibilities include leading the team, building circuits, writing the code for their device, debugging, managing time, and much more. And so we recommend that students rotate through these roles as they rotate through the various projects. And this gives them the opportunity to practice and hone their abilities to develop those 21st century skills, such as creativity, perseverance, problem solving, and critical thinking. After students complete their projects, they're encouraged to present their projects to the rest of the class. When students show off what they've created, they can take pride in their hard work, what they've done to solve these technological problems. Students can share about the difficulties they faced and what they would do to take their project to the next level. By presenting their projects, students can receive feedback and suggestions from their peers. That classroom collaboration that allows for deeper learning as students reflect and evaluate on their projects and processes that they've gone through. All right, so before we go any further, we want to take a look at the online platform for delivering the content. So we're going to jump off of the PowerPoint and I'm going to share my screen. And you can see here that I'm logged in to the online platform using my account. Over here, this is our profile, and we can go to, right now, I've just gone to my courses. I was already there. I don't know why I clicked on it again. All right, so this is kind of the dashboard for your account. Over here, you have access to several things. The first thing we want to look at is members. This is where you go to add teachers or add students. So you can add as many teachers, as many students as you want. You've got different roles here that you can create accounts for. So that's kind of your classroom management area. If we go back to courses, you'll see a button here for register kit. Every kit has a unique code on it, and it's on the back of the lid. So when you get your kit to open it up, there's a code there on the back of the lid. You go to the URL, it's also shown on the back of the lid. You put that code in, and that will register your kit, and that will associate it with your Arduino account. Or if you don't have one, it'll help you. It'll lead you to where you can create that Arduino account. So once your kit is registered and connected to your account, then it will show up as an available course right here. So here's CTC GO. We're going to go ahead and jump into CTC GO right here. And it's going to load up and take me to the splash screen. And you can see the two parts here, the digital IO part 1, the serial and analog part 2. I'm going to also, you've got some navigation up here at the top. So we're going to jump into the core module, and we're going to just jump into lesson 1 right here. Remember, we said that there were 4 guided lessons before you go through the 4 activities for part 1, or 4 projects. And then 4 new lessons for part 2 before you do the 4 activities for projects for part 2. So we'll jump into the Get Inspired lesson. All of the lessons and projects have a similar format. And so over here on the left, you've got your navigation. This can jump you to anywhere in the project. You've still got your navigation up here at the top where you can get to the glossary or jump to any other lesson. But as we scroll through here, here's an estimated time for completing. So every lesson is about 45 minutes, about 1 class period. We've got the concepts that we're going to learn. And now here you can see these brown boxes. These are notes specifically for the teacher. These don't show up for the student. And so inside of here is going to give us all kinds of information that's important to the teacher, such as the teacher guides. You can access those, what the students are going to be doing as they go through the lesson, extra video content that's specific for the teacher. These teacher notes, you can toggle those on and off as the teacher. So clicking this little icon over here turns those on and off. The students don't have that capability to do that. Again, they're only going to see the student content. But when I turn that off, I'm seeing it just as the student would see it. So let's go ahead and we'll keep that on for now. So here we've got our learning objectives. And then here's all the materials I'm going to need for this lesson. And then we jump right into the content. And it's going to walk me step by step through teaching me the electronic fundamentals, the coding fundamentals. I don't think there's any coding in this first lesson. But everything I need to learn the concepts to be able to do those projects a little bit later. So let's jump in. We'll look at a project here. Let's just jump into the finger race. You can see that it has the same kind of format. We've got the navigation over here on the left where I can jump to any part of the project. And then as I scroll through here, I've also got the teacher content that I can toggle on and off. But there's this difficulty level. And this is a really cool thing for you as the teacher. You can assign projects based on these difficulty levels to different groups. So if you've got a group of students that's really kind of struggling with these concepts, you might give them a project that's a little bit easier. And if you've got students that are really excelling, then you might give them the more advanced project. Now, remember, you can always have students rotate through these projects as well and not just do one of them.
Sure.
And so as we jump down here, again, here's the teacher guides that are available. And here is the solution code for the teacher. So right at the bat, we're giving you the entire code for the project. And so that's useful for you as the teacher, as you're trying to help students troubleshoot their code, what they might have done wrong. You've got the answer that you can compare to what students are coding.
That all important safety net.
Yeah. So again, similar format. We're going to give you all the components that you're going to need to build the project, assembly videos on how to put it together. Here's wiring schematics or wiring diagrams, I guess, for wiring up the circuit. And it walks you step by step through that. And then we get into the code, and we're going to give students the code kind of line by line or section by section as we're explaining that code. Now, the code isn't explained as much here because it should have been explained in the lessons themselves. So here it's going to tell you more about type this line of code.
Sure.
You'll see a lot of times that there will be blanks and students need to fill in those blanks based on their understanding of the code and whatever, like whatever pen they're using
Sure.
on their board or whatever. So we give students line by line or section by section the code, and then they can see what the expected behavior is, and then they just work through every project has several sections that they're going to work through before they get to the end to complete the project. One thing I wanted to point out was at the end, there's always a challenge section to take and extend the project a little bit further. And so the time for completing this is not considered in that 135 minutes or 3 class periods. And so if you want students to complete the challenge, that's another way to extend the content.
Sure.
By having them do that challenge. So that's a look at the content itself. I think we will go ahead. I'm going to stop sharing here and we'll jump back over to the PowerPoint.
So awesome. So besides the CTC Core Go core module, there's also the expansion module called CTC Go Motions.
Yeah. So the Motions expansion is an add-on to the core module. It can't be used by itself. That's important.
One more time. Say it one more time.
It cannot be used by itself. So it's an add-on. So students need to learn all of the fundamentals, the fundamental concepts that they'll need from the core module before they go into the Motions expansion. Yeah, so they'll also need the hardware from the CTC Go core module. They're going to use that same hardware with the Motions expansion.
Okay. So let's go ahead and do it just like we did for the core module. Let's start with a general overview. So before we get into the specifics.
Okay. So CTC Go Motions, the expansion module, it's also recommended for students ages 14 through 17, so same age range. The expansion deepens students' programming and engineering skills by showing them how to add motion and movement to their projects. The kit introduces new and more complex programming concepts that develop logical reasoning, computational thinking, and those all-important problem-solving skills. The projects in the kit combine many of the parts and components from the core module with the elements of the motion pack. So students are encouraged to be creative as to how they use motors and servos to make their projects move. As for the key learning values, by combining the Motions expansion, students will understand the basics of servo control and motor movement, both rotationally and how to get linear movement. They also learn how to translate that motion by using gears and pulleys. They'll expand their programming knowledge and skills as they learn to control multiple actuators using sensor data. They'll be creative as they use different resources and technology to design and develop physical computing projects. And then just like the core module, students work collaboratively to solve real-world problems by following that design process.
And again, like the core module, the expansion pack serves 24 students by dividing the classroom into 8 collaborative groups of 3. Students are encouraged to change roles as they rotate through the projects, and each project includes time for groups to present, so the knowledge can be shared, and so classmates can help troubleshoot problems that the group may have encountered.
Yeah, the motions expansion is geared toward different goals than the core module. It's meant to build upon students' existing knowledge from the core module. The motions expansion pack, they're going to continue to work with and apply the components and programming concepts that were introduced in the core module, but the motions lessons don't spend much time reviewing or going back over that same content from the core module. It might just be a quick reminder or refresher sometimes. That might be all they get. And so they're really expected to really apply what they learned from the core module before they get into the motions or as they're getting into the motions. However, students will learn how to read and understand and reuse existing code from their previous projects. So that's just like a real engineering professionals would do.
Okay, but you're scaring me just a little bit because you said that the motion expansion has different goals. Does that mean that the learning platform is different?
Yeah, so actually the answer to that is no. The motions expansion uses the same learning platform as the core module. It includes those all-important step-by-step instructions, walking you through the activities, the guided lessons, the assembly videos and diagrams. There are short quizzes to recap knowledge, and then those challenges that we talked about. But additionally, there's an after-class section that encourages students to explore the world outside the classroom to make those connections, those real-world connections to the lessons that they've been learning. It has the exact same format as the core module.
And from a hardware perspective, from my understanding, it uses the same electronic components as the core module with the addition of the hardware that comes specifically within the motions expansion. And that would include things like wheels, pulleys, servos, and motors.
Yep. And like the core module, students can program their motions expansion projects using either the offline IDE or the web IDE. Now, the student lessons and projects content is structured in much the same way. We mentioned that as the core module that we saw earlier. This includes sections for introduction, the learning outcomes, the time estimates, the media-rich instruction, materials lists, coding instructions, circuit diagrams, all those challenges, and a lot more. The teacher's content works exactly the same way as well, with extra information such as the lesson guides, the tips, the discussion questions, that all-important solution code that can be toggled on and off. There's also a project reflection sheet for students, and that can be helpful for them to reflect on their projects as they complete them.
Now, you just briefly mentioned time, but the motion expansion pack contains 10.5 hours of instructional programming, electronics, and assembly activities. The content is divided into 14 separate 45-minute sessions across the 3 main parts: guided lessons, guided projects, and the final self-designed project. And it follows the same pattern as the core module. There are 4 lessons and 4 projects. And just like the core module, these times can be extended by having students complete the challenges at the end of each lesson and project.
Yeah, so during the guided lessons, students will learn about new components, new electronic components, and new programming concepts as they're learning about mechanics. Remember, it's all about motion and movement. When they're working on their projects, students get to tackle real-world problems and generate solutions using the knowledge and skills that they've developed as they've worked through the CTC GO content. Now, half of the program is devoted to a self-design project. This allows students to develop their own projects based on their interest, using the skills and knowledge that they've gained as they've gone through the lessons and activities. It also provides the opportunity for students to use their creativity and imagination while continuing to hone their skills in electronics, programming, and mechanics. There's an outline that's provided to help students plan, design, develop, and then present their projects to the rest of the class. All right, Tim, so let's talk about some of those guided projects. This is your favorite part, right?
The projects, I love the projects. So in rock, paper, and scissors, everybody remembers this one. Students generate and program a robotic companion to play the classic game. So it's you against the robot. An ultrasonic sensor is used to track the human movement, while a robotic arm, LEDs, and a buzzer are used to randomly select the robot's choice.
So it's you versus the robot.
You against the robot.
All right.
Mono, well, it's not mono a mono though, then,
No.
is it? No.
Mono
Well, anyway.
robot.
There you go. Then there's the wave generator. This is a more artistic project that interprets human movement and uses a moving pen and a rotating paper scroll to represent this motion as a quirky wave pattern. And no, I am not a dancer, so I'm not going to see me do any wiggly wave pattern.
No gyrations.
No gyrations from the old
Okay.
man. So then finally, there's the Wiggler. This is a light sensing autonomous robot that drives around the classroom. Students can direct the robot around obstacles with a flashlight.
Yeah,
So-
I think we saw that in the video.
Yeah, and whenever the flashlight goes, or wherever the flashlight goes, that's where the Wiggler goes.
All right, so that's 3 of the project. There are 4. We've only shown 3 here, but
Okay, so I think, are we ready for questions and answers?
yeah, so I think that's it for CTC Go core and motions module. Steph, did we have any questions that came up as we
Yeah.
were going through that?
We had one question. What are the fees for the online module components? Is the fee annual or a one-time fee? And are there limits on the number of students that use the same kits, such as if the kits are used for several classes?
Okay, so that's a great question.
Yeah.
What you're doing when you buy the kit, you're buying the hardware, and the hardware comes with the content. So there are no fees particularly for using the online content. Yeah, so that just comes with the hardware that you're buying. You can add as many students to your classroom as you want to go through that content. You can add as many teachers as you want to go through that content. That's something that Arduino has changed. Last year, they changed that, which really opened it up. The thing that you're limited by is your hardware. You've only got certain number sets of hardware. And so how many students you can have going through the content at one time is dependent on how much hardware you have. And that depends on how many of the core sets or the motions expansion packs that you've purchased.
And it's to how long the hardware will last. Again, because they're using breadboards and you're not having to solder components, the components can be reused. Now, again, you have to kind of, the reality check is they're small components, there's thin wires, stuff like that. So if they're abused, obviously you can ruin a component, but you can always buy extra. But they should be, and they are designed to be used multiple times and reused over class period by class period. So they can be used multiple times.
Yeah.
Does that answer the question, Steph? I think, did we get everything?
Yes,
Okay.
yes.
Anybody have anything else?
Awesome. I guess we did our job.
Yeah, that's
Hang on, we
like,
have another one.
Oh, all
oh,
right.
okay.
Does this unit work with the original Arduino?
It does not work with the original Arduino Uno. That's what I'm assuming you mean. It uses a new version of the Arduino. It's the Arduino
Rev 2.
Rev 2, and that's because of that education shield that needs to set on top of it.
Yeah, so that's the only, I mean, that's kind of a tricky question to answer because the curriculum has all been written around one specific board, in this case, the Rev 2, you know, so and the shield as well has been designed specifically for that. So they work together. But you know, it's an Arduino board. So as far as from the software perspective, that part would work the same.
Yeah.
You can always download code from, you know, regardless of the board within the software. So they work all that way together. But to keep everything aligned with the content and stuff, it's going to expect that you have the Rev 2.
Yeah.
All right, another question. Are you currently developing more expansion packs?
That's a good question.
And we'd love to have Arduino chime in and answer that, because that's something that we, again, because of our partnership, they haven't told us that they are, but I'm sure that they probably are. They're always developing new products, which are always amazing.
Yeah.
But sometimes we don't know too much earlier than you folks do.
Okay. Can you please repeat the amount of time with lessons and projects? So how much content are we talking about with CTC Core and CTC Expansion?
Yeah, so with the CTC GO, there are 8 lessons and 8 projects. So each lesson is designed to be 1 class period, so 45 minutes per lesson. So that's 8 days. And then you've got, if you do a rotation of, if you don't rotate through the project, so you just do 1 project time per module, remember there, or per part, there's 2 parts. So then that's an extra 6 days. And then you've got the added on time at the end for the student's guided project or the student self-directed project. So that adds up to about 20 class periods of content. That's the minimum. That can be extended up to 38 or even more class periods, depending on how many rotations of the projects you want students to go through. So if you want them to rotate through 2 of the projects and do 2 of those rather than just 1, that's an extra 3 days. 3 of the projects would be an extra 6 days. And then all 4 projects rotating through all 4 would be an extra 9 days, giving you up to 38 days. But then if you do, remember we talked about the challenges that are in each lesson and each project, that's not included in that time. So you can extend that even further by having students do those challenges at the end. And that's just for the core module.
Yeah.
For the motions module, it was half of that basically. It was 14 days. That was 7 days for the guided projects and 1 rotation, 1 project rotation. And again, you can have students rotate through those different projects, 3 days per project, 3 class periods or 135 minutes. And then you can always extend that further by doing those challenges at the end of each lesson and each project.
A bunch, a lot of time.
Yeah, so it's up to you as the teacher. But the minimum is 20 days for the core, 14 for the expansion, motions expansion.
Okay, hang on. I think we have another question. Are there help forums or other webinars or other resources to help get started?
Yeah, that's a great question. There are online resources for you as the teacher to help you get going. There are webinars that you can schedule with Arduino to help you get going. They're always just a fingertip away or a button press away. Yeah, so there are lots of resources to help you get going. There's PDF documents you can download. There's a forum where you can go on. If you by creating your Arduino account, you also have access to the Create platform, where you have the project hub where you can go see thousands and thousands of projects that everyday people, makers are creating with Arduino products.
For those folks that are not have never been exposed to our Arduino, this is one of the probably the biggest strengths that they have going for them, is the fact that they have such a strong community base. And everybody, as if you've ever been tried this at all, is incredibly gracious and incredibly helpful, that if you just post in one of the forums, there is somebody somewhere across the world that is going to be eager to help in any way they can. So again, it's probably one of the most strongest strengths for the Arduino platform is their community base and their forum, because it's so easy to use that there's people all over the world that are using it.
Yeah, and then I didn't show this part of it, but when you are logged into your core module, up at the top, we had those 3 categories: the modules, you had access to the glossary. There was also a place right there where you could book a webinar if you needed that extra guidance.
Okay, I don't see any additional questions. Give everyone just a few more seconds. Great, thank you. Thank you for joining, Katrina. Okay, if there's no more questions, want to thank everyone again. Thank everyone again for joining us today. Our session has been recorded and the recording will be sent out to all the registrants and attendees by email. Though again, just as a reminder, those who attended live today will also receive those certificates of attendance through email as well. Also, if you'd like to learn more about either of the CTC GO kits presented today, you can do so at pitsco.com/Arduino, and there you will find the complete assortment of Arduino products. Thank you again to our presenters, Tim and Aaron, and to all of the attendees for joining today, and hope everyone has a great rest of your day.